right, hello everyone. We are now ready to talk about what an arithmetic series looks like. But actually, we need to go back a step here and take a look at one extra problem that we can do for an arithmetic sequence. So let's get to it. So our question here says that I'm giving you two random terms of an arithmetic sequence, and I'm asking you to find a rule for them. So I'm giving you the third term is 5 and the eighth term is 20. Now, we don't know what the first term is and we don't know what the common difference is. We would need those pieces of information to plug into our formula up here to figure out the rule. We can be creative though, and we can actually figure that out. So let's take what we do know. I know a sub n. If I take the third term here, I know that the third term is 5. So I can plug 5 into this spot into my formula. I also know n. N is right here. N is 3. So I can use the 5 and the 3 and plug them in here and there and write an equation. Now it's an equation where I don't know A1 and I don't know D. But if we remember in algebra, if I have two unknowns, I can use two equations and solve for it using elimination method or substitution method. It's just a system. So let's do that same thing for the eighth term. I know that it's 20 and n is 8. So I can write another equation where 20 is equal to a sub 1 plus n minus 1, which is 8 minus 1 times d. All right, so let's clean up these equations a little bit. I just subtracted. And now I am ready to eliminate. I could do substitution. If you prefer to do that, go right ahead. But I like elimination when both of these terms have the same coefficient. It's very easy to just subtract them from each other and get my answer. So 5 minus 20 is negative 15. A minus A is 0. And 2d minus 7d is negative 5d. And now I can divide by negative 5. All right, so now that I have d, I can plug 3 into either one of these equations and solve for a1. So why don't you go ahead and try to do that and figure out what a1 is. All right, so I chose to plug it into this equation. I plugged 3 in for d, and I got a sub 1 is negative 1. Now that I have the common difference in the first term, I can just plug them into this formula and simplify. So now it becomes a problem like you did on yesterday's assignment. All right, so working through the algebra, distributing the 3, combining like terms, I get my rule. All right, so now we're ready to go on to series. So I'm going to give you a little story here, very abbreviated, about how the formula for the sum in an arithmetic series came to be. So the story goes that the famous mathematician Gauss, when he was a little kid in primary school, he was really annoying his teacher, and the teacher tried to give him a task to keep him out of her hair and said, hey, go in the back corner somewhere and go add up the numbers from 1 to 100 and tell me what the sum is, thinking that that would take him forever to do. Well, he came back like a minute later with the answer, and this is what he did. So he listed out the numbers 1 through 100, adding them up like that, and then he listed them out again underneath it, but going backwards. So starting with 100 and going down to 1. And then if you add each pair, so add these two lines together, each time you add, you get 101. So now all you have to do is how many 101s do you have? Well, we have 100 of them because we went from 1 to 100. So the sum is 100 times 101. But wait, that was two sets of 1 to 100. We only wanted one set, so we just have to divide by 2. And you get your answer of 5,050. So really, if you take what he did, he took the first term, which is 1, added it to the last term, which is 100. That's how we got 101. And then we had 100 of them, so that's the number of terms. And then we had to divide by 2 because we didn't want doubles. So there's our formula. that's how that came to be. Pretty cool, huh? Okay, so this is the formula that we need to get familiar with and work with. So here's our first problem. What I'm going to have you do is, first of all, write down the 8 minus the 2k, right? But we need to figure out how to use this formula. Things that we need to look for. We need to know what n is, and we need to know what the first term is, and we need to know what the last term is. That's what a sub n represents in this formula. Remember from that previous example that I showed you, it's first plus last. So when I have a series written in sigma notation, figuring out the first term is pretty easy. I just take whatever value they're telling me to start with for k, and I plug that in. So let's do that. A sub 1 is going to be equal to 8 minus 2 times 1, and we get 6. Okay, so now we have to find the last term. Well, the last term comes from when I plug the last number, or the number on top, in for k. So let's do that. A sub 5 is equal to 8 minus 2 times 5, and that's negative 2. All right, great. So we have the 6 and we have the negative 2. Fantastic. We need to figure out n. So this is where you have to go back and you have to look at how many terms are we actually going to get. If we start with k equal to 1 and we count out how many terms we have terms when k equals 1, 2, 3, 4, and 5. That's 5 terms. So n should be 5. All right, now that we know n is 5, now I can plug everything into my formula and I get 10. So the sum is 10. All right, great. Now let's move on to another way we can do this. What if I didn't give you the series in sigma notation? What if I gave it to you as the first 3 or 4 terms, and then I tell you how far to add to? So like only add till you get to 10 terms. Now, I know 10 is pretty small. You could probably sit there and manually write out the next 7 terms and then just add those numbers together. But imagine if I asked you to find the sum to 158 terms. You probably are not going to want to write down 155 terms to figure that out. Okay, so this is where the formula is going to be useful. All right, so first of all, we have a sub 1. They gave us the first term. That's great. We have this. We have n. That's 10. So we have 10. The thing that we're missing is the a sub n. So we need to figure that out. So that's where we're going to use this formula again. See, this formula doesn't go away. We keep using it, whether you're dealing with a sequence or a series, because it just helps you find a specific term, right? All right, so let's take this formula and plug in 7 for a sub 1. Let's plug 10 in for n. Can we figure out what d is? Yes, we can, because we can look at the 3 terms that we have here. It looks like we're adding 5 each time. So d is 5. So let's plug in everything that we know and figure out the 10th term. When we simplify this up and work it out, we get the 10th term is 52. Okay, so now that we know a sub 10, that's the number that's going to go in this slot. That's the last term. We can plug in 7 here, and we can plug in 10 up there. So we plug everything in, we work it out, and we get our answer. And that's it. Okay, so now I'm going to have you do a problem. All right, so I hope that you were able to figure all that out and work through that problem pretty easily. Once again, if you have questions, please let me know. I'm happy to clear up any confusions that you have. All right, talk to you later, guys. Bye.